In this buffer solution, H plus ions present, OH minus ions also present. Now we are adding HCl into this buffer solution. HCl gives H plus ions into the buffer solution. Buffer solution removes the added H plus ions. This buffer solution removes the H plus ions provided by the HCl. So HCl giving H plus ions not present in the buffer solution as free form. Therefore, HCl provided H plus is not present in the free form in the sense the concentration of H plus in the buffer solution is not changing. Therefore, pH of buffer solution is not changing. Sir. So, what is the conclusion means? We have taken the buffer solution. This buffer solution contains H plus ions as well as OH minus ions. Depending on the concentration of H plus and OH minus, we can say whether it is acidic or basic. Here we have taken acidic buffer, therefore H plus concentration will be high when compared to OH minus concentration. Therefore, this solution is acidic. This buffer solution pH is this buffer solution pH is coming under a less than 7. Sorry. Now, shall we say that acidic buffer solution is always having pH less than 7? Acidic buffer solution is always having pH less than 7. Can we say that? We cannot say. Acidic buffer means pH is less than 7 only. Like this we cannot say. Sir. Anyhow, buffer solution means H plus ions and OH minus ions both will be there based on the concentration of H plus ions. Buffer solution will have some pH. Okay. What is the theme of buffer solution? It will resist the change in pH on adding small amount of acid or base or solvent. That is the theme of, that is the goal of a buffer solution. Buffer solution will resist the change in pH. Sir. Now we will let us add small amount of HCl. We have to add small amount only, not large amount. If we add a large amount, if this amount is greater than this, then resultant solution will be this one only, no, this nature only, no. Therefore, to the buffer solution, we are adding acid in the sense how much we have to add? Small amount only we have to add. Sir, we are adding small amount of HCl into the buffer solution. This HCl gives H plus ions into the buffer solution. The H plus given by HCl will not be present as free. The H plus provided by HCl should not be present free in the solution. If the H plus provided by HCl is free in the solution, then concentration of H plus changes, then pH changes. Then the aim of a buffer solution will not be maintained. So buffer solution means what? It has to resist the change in pH. It will not allow the solution to change the pH. It will keep the solution to have same pH value, though external disturbance is there. That is the aim of buffer solution. Sir, so we are adding, now we are adding HCl. We are adding HCl in the sense HCl is a strong acid. It will dissociate completely. It will give H plus ions. Then this solution, what it will do now, buffer solution, the species present in the buffer solution will remove H plus provided by HCl. Removing in the sense what? Consuming. The species present in the buffer solution consumes H plus ions provided by HCl. Consumes in the sense the H plus ions from HCl is not free in this solution. Is not free in the sense concentration of H plus in the buffer solution will not change due to addition of HCl. Therefore, pH of buffer solution will not change. Okay, it is this is the role played by buffer solution. So, on adding small amount of acid, buffer solution maintains the pH to the same value though external disturbance is given. Even then, pH changes some extent. Some change will be there, but not like normal solutions. So, now we will see in buffer solution how the pH changes, in normal solutions how the pH changes. Both we will see. Then why we have given the name buffer solution? Why do we say definition of buffer solution is it resists the change in pH? That means it keeps the pH remain same. Why do we say that word? That we will see. Okay. Now we added how much HCl in the sense 10 power minus 3 moles of HCl. That HCl gives H plus ions. So H plus ions provided by HCl is this much. H plus ions provided by HCl is this much. Okay. Now, what buffer solution has to do? Buffer solution has to remove this H plus. Buffer solution should consume this H plus. Therefore, this H plus ions should not be free. This H plus ions won't be free. Sir. Now, which species in the buffer solution will consume this H plus? Which species present in the buffer solution will consume this H plus? No, acetic acid cannot. H plus ions cannot. Sodium ions cannot. So, is there any species in the buffer solution to consume H plus? Yes. Which species? Acetate ion. Acetate ion will consume this H plus. Acetate ion present in this buffer solution will consume H plus provided by this HCl. So this HCl providing H plus, that is consumed by acetate ion. Okay. Now acetate ion, how much is there in the buffer solution? You multiply this molarity, salt molarity and volume of solution, you will get number of moles of acetate ions. Multiply, how much you are getting? 1 mole. Okay. So 1 mole of acetate ions we are getting. This acetate ions will consume H plus. Therefore, H plus will be consumed. So H plus will be removed from the solution. So H plus how much present means nil from HCl. HCl provided H plus is consumed completely by the acetate ion. So acetate ion takes H plus and becomes what in the sense acetic acid. How much acetate ion is converted into acetic acid means how much H plus it consumes, that much acetate ion converts into acetic acid. So how much acetate ion is disappearing? This much. This much acetate ion is disappearing. How much acetate ions remaining? How much acetate ions remaining in the sense this much. This much acetate ions remaining, we can say. This much acetate ions remaining. How much acetic acid produces? This much acetic acid produces. How much acetic acid present already in the buffer solution? This molarity and volume of solution you multiply. How much you are getting? 1 mole. So 1 mole of acetic acid present in the buffer solution. So how much acetic acid now present? This much acetic acid now present. Now we will see pH of the buffer solution. Okay. Why to see pH of buffer solution? This acetic acid will go for equilibrium or not? Yes or no? Yes, it is going. Okay. So this acetic acid is going for equilibrium. This acetic acid will be in equilibrium. That equilibrium is what in the sense? So and so. That equilibrium is so and so. Okay. Now, here also equilibrium is possible. What is that equilibrium in the sense? That is so and so equilibrium. So and so equilibrium. Now, because of this equilibrium, H plus ions present in this solution, therefore this solution is having pH, that pH is equal to how much we said in the sense pKa. Here for this buffer solution, pH is equal to pKa, we can say. For this buffer solution, pH we will see. So pH is equal to what in the sense pKa plus log salt by acid. Salt is how much in the sense acetate ion, that is acetate ion is 0.099 moles by acid. Acid in the sense 1.001 mole. 1.001 mole. It is the pH of this buffer solution. Now pH of buffer solution. Here pH of this buffer solution is what in the sense pH is equal to pKa plus log salt. Salt is how much means 1. Acid is how much means 1. Therefore we said pH is equal to pKa we said. Now you say this buffer solution is having pH. We added HCl into this buffer solution. HCl provided H plus. That H plus is consumed by acetate ions present in the buffer solution. Therefore, what had happened means acetic acid concentration raised. On rising the concentration of acetic acid, dissociation extent of acetic acid increases. Therefore, concentration of H plus in this solution will be greater than concentration of H plus in this solution. Therefore, pH of this solution is lesser than pH of this solution. Correct? Sir, that means we said one definition for a buffer solution. What is the definition means? Buffer solution will not change its pH. Buffer solution will not change its pH on adding acid, small amount of acid. But what happens here? pH changing or not? pH changing. Then why do we say that definition? Here you see the pH of this buffer solution. Now you see the pH of this buffer solution after adding HCl. pH is different or not? Yes. This pH is less. This pH is less. This pH is more. pH is changing. Then why did you say the definition that buffer solution means it is not changing its pH on adding small amount of acid? So we will check in another way. Okay. Now we will take a aqueous solution of sodium chloride. This 1 molar will take, 1 liter will take. Sir, in this aqueous solution of NaCl, sodium ion is not undergoing hydrolysis. Cl minus also is not undergoing hydrolysis. Here, what is the equilibrium present means water is in equilibrium with H plus and OH minus. Only this equilibrium is possible. At 25 degrees Celsius, H plus concentration is 10 power minus 7 molar. OH minus concentration is 10 power minus 7 molar. Therefore, pH is equal to what is the formula means minus log of H plus concentration. If you substitute, you will get pH is 7. Therefore, this is a neutral. Why it is neutral in the sense concentration of H plus equal to concentration of OH minus in this solution. That's why. Now let us add a 10 power minus 3 moles of HCl. 10 power minus 3 moles of HCl we added into this solution. Therefore, now concentration of HCl in the resultant solution becomes 10 power minus 3 moles in 1 liter of solution. Here 1 liter we have taken. Therefore, concentration is 10 power minus 3 molar. HCl dissociates completely. Therefore, it gives H plus concentration 10 power minus 3 molar. Now we will substitute this H plus concentration in the pH formula. We will get pH is 3. You see the pH. pH of this solution is 7, but pH of this solution is 3 due to addition of HCl. Here, how much HCl you added, that much is dissociating to give H plus. The produced H plus ions present free in the solution. HCl giving H plus ions is not consumed by anybody in this solution. HCl provided H plus ions present as it is in the solution. Okay. Therefore, you are adding HCl in the sense that is giving H plus ions, that H plus ions present as it is in the solution. So the HCl giving H plus ions is completely free. Therefore, pH is changing. pH is changing in what way? In what manner you are adding? In what quantity you are adding HCl? Proportionate of pH is changing. But in this buffer solution, what happens? You are adding HCl. HCl is giving H plus ions. HCl gives how much H plus ions? That means small amount of HCl we have to add, not large amount. If you add large amount of HCl, then resultant solution is not buffer solution, that is HCl solution. Okay, so add small amount of HCl. On adding small amount of HCl, that HCl giving H plus, that H plus ions consumed by the species present in the buffer solution. Therefore, acetate ion consumes complete H plus ions. Therefore, we are getting acetic acid. Due to increase in the concentration of acetic acid, the dissociation extent of acetic acid increases. Therefore, H plus concentration increases here. But acetic acid is weak acid. Therefore, what is the concentration of acetic acid increases, that much dissociation won't be increased, since it is weak acid. Therefore, slightly concentration of H plus changes. Okay. Therefore, due to addition of HCl, concentration of H plus, what happens means increases slightly. Due to addition of HCl into this solution, concentration of H plus increases slightly. But in this case, due to addition of HCl, concentration of H plus increases proportionate to this. So to this solution, on adding HCl, concentration of H plus increases proportionate to this. But in this case, concentration of H plus increases slightly. Therefore, here also pH decreases, no doubt. pH decreases slightly, we can say. pH decreases slightly. But in this case, pH decreases proportionate to addition of HCl. So that here pH decreases normally, but in this case pH decreases slightly. Therefore, only superficially definition of buffer solution is given. It is not allowing change the pH. It is not allowing to change the pH, we are saying. Superficially we are saying. Okay, but actually what is the meaning? Why we are saying like that definition? It is not allowing the pH to change. Why we are saying that definition? Because the added H plus is consumed to some extent, is consumed completely. But due to therefore acetic acid concentration increases, therefore dissociation extent increases, therefore concentration of H plus increases. But acetic acid is weak acid. Therefore, due to addition of HCl, concentration of H plus increases slightly, pH decreases slightly. That's what we can say. Okay, superficially, the definition of buffer solution, what we will say means it will resist the change in pH. It is not changing the pH, like this we will say superficially. Okay, sir. Now, in the buffer solution, if we add acid, pH is decreasing slightly, we can say. Suppose if we add base, what will happen? We will take a buffer solution. To the buffer solution, we will add base. What will happen to the pH? That we'll see. Okay, sir. Now we will take the buffer solution. The buffer solution is what in the sense acetic acid and sodium acetate. Acetic acid is 1 molar, sodium acetate is 1 molar, volume of solution is 1 liter. To this, let us add sodium hydroxide, which is strong base. So we have added sodium hydroxide. The added sodium hydroxide dissociates to give hydroxide ions. How much hydroxide ions means? This much hydroxide ions. This much hydroxide ions produced. Okay. Now, what buffer solution has to do? Buffer solution has to remove this OH minus. Buffer solution has to remove the added hydroxide. So we are adding sodium hydroxide. Sodium hydroxide gives OH minus to the solution. That OH minus should be removed by the buffer solution. Which species will remove that OH minus? In the buffer solution, which species will remove the added OH minus? OH minus in the sense base. So in the buffer solution, which species is having acidic nature, that species will remove this OH minus. That means what? How it will remove? Acid-base reaction, acid-base neutralization. Somehow the added OH minus should not be present. Added OH minus should be removed from the solution. Removed in the sense what? It should not be free. Okay, like this we have to do it. Sir, therefore, in this buffer solution, which removes the added OH minus in the sense acetic acid, because that is having higher acidic nature when compared to other species present in the solution. Sir, therefore, acetic acid removes this OH minus. That means acetic acid reacts with this OH minus and becomes what in the sense acetate ion and water. Like this reaction takes place. How much acetic acid present in this buffer solution? Multiply this 1 molar and 1 liter, you will get number of moles of acetic acid. That is how much in the sense 1 mole. So this acetic acid removes this OH minus we are saying. Okay. So how much OH minus is removed in the sense? Completely OH minus is removed. Okay, the added OH minus is removed completely. So how much acetic acid should be consumed for that? Same amount of acetic acid should be consumed. So this much amount of acetic acid is consumed. So how much amount of acetic acid is remaining? Remaining acetic acid is this many moles. This many moles of acetic acid remaining. How much acetate ion is producing? How much OH minus is consumed? That much acetate ion is producing. Okay, this much acetate ion is producing. How much acetate ion we have taken initially? Multiply this 1 molar and 1 liter, you will get number of moles of acetate ion initially we have taken. We have taken initially this many moles of acetic acetate ion. How many moles of acetate ions now present due to addition of sodium hydroxide? This many moles of acetate ion present now. Okay, shall we calculate pH now? Okay, now we are calculating pH of buffer solution. pH is equal to pKa plus log salt by acid. Salt is how much in the sense 1.001. Acid is 0.099 mole. Now we got pH. Now pH of this buffer solution we'll see. pH of this buffer solution is equal to pKa plus log salt is 1 mole and acid is 1 mole. Now you see this pH and this pH. What happens to the pH? Due to addition of hydroxide, pH getting raised slightly. pH raised slightly, we can say. That's what it is showing. You see the result. pH is high or not, you see. This solution pH is high when compared to this solution, but not normal. pH increases slightly, we can say. Okay. So buffer solution in the sense, what is the definition? Buffer solution means pH is not changing. Like that only we have to say. Buffer solution means pH does not change. That is superficial. But actually what happens? Changes slightly, not normal. Okay, sir. So pH changes slightly. Here what happened? pH increased. Why pH is increased? The added hydroxide is removed completely, no? When the added hydroxide is removed completely, then how pH can change? How pH increased slightly? In the previous case we said, here we said we are adding HCl. The H plus given by HCl is completely consumed by acetate ion, but that is converted into acetic acid. Therefore, concentration of acetic acid increased. So, extent of dissociation increased. Therefore, H plus concentration increases slightly. Therefore, pH decreases slightly, we said. Now, in this case, added hydroxide is removed by acetic acid, then how pH will increase slightly? Because added hydroxide is removed or not? That means here also acetic acid will be in equilibrium. Acetic acid will be in equilibrium like this, isn't it? Acetic acid will be in equilibrium. This hydroxide takes this H plus and becomes water. This hydroxide is given by sodium hydroxide. This hydroxide takes this H plus and becomes water. Therefore, concentration of H plus, what happens in this solution? Decreases or not? Concentration of H plus decreases or not in this solution? Decreases. Concentration of H plus in this solution decreases means pH increases. Yes or no? But this hydroxide removes this H plus means immediately concentration of H plus is getting reduced here. Therefore, equilibrium disturbed. Forward is favoring. Yes or no? Forward is favoring in the sense some more acetic acid is converting into acetate ion. Therefore, H plus will be reproduced, though reproduced, not normal. Because equilibrium once disturbed in the sense new equilibrium only we will get, but not same equilibrium as like old. New equilibrium we are getting in the sense position of equilibrium is changed. Position of equilibrium is changed in the sense concentration of H plus will be changed. So concentration of H plus in the new equilibrium and concentration of H plus in this old equilibrium certainly different. So concentration of H plus in this new equilibrium will be smaller than concentration of H plus in this old equilibrium. Therefore, pH increases slightly. Okay, sir. So due to addition of base, what happens means the buffer solution consumes that base, but even then pH increases slightly. Okay, sir. So on adding base, pH increases slightly. We can say on adding acid, pH decreases slightly. Okay, not like normal. Sir. So in buffer solution, how the buffer solution neutralizes the effect of addition of acid and base to some extent. That's what we have seen. Sir, if it is acidic buffer removes added H plus and added OH minus like this. Now we will take basic buffer. How basic buffer neutralizes the effect of addition of acid and base, that we will see. Now we will take what in the sense basic buffer we will take. Basic buffer example we will take ammonium hydroxide and ammonium chloride. Now to this let us add acid. The added acid gives H plus. That H plus should be consumed by buffer solution, isn't it? So in the buffer solution, which will consume the added H plus? Base will consume, that's all. Which is the base? Ammonium hydroxide is the base. So ammonium hydroxide consumes the H plus. So that this in the ammonium hydroxide, the hydroxide takes H plus and becomes water. In ammonium hydroxide, what is the remaining means ammonium ion is the remaining. So the added H plus is removed like this. So in this basic buffer, the ammonium hydroxide removes the added H plus from the HCl. Suppose if you add sodium hydroxide, into the buffer solution, the sodium hydroxide gives OH minus ions to the buffer solution. In the buffer solution, which will consume this OH minus? Only possibility, ammonium ion has to consume. Ammonium ion has to consume. Ammonium ion consumes this OH minus and becomes ammonium hydroxide. It is weak base, therefore it will not dissociate completely. Okay, therefore here what happens means ammonium ion consuming hydroxide and becomes ammonium hydroxide. So now we came to know how the buffer solution neutralizes the added H plus ions, and added OH minus ions to some extent, that we have got an idea. Okay, sir. So conclusion we can say in the acidic buffer, the conjugate base consumes H plus, sorry, and weak acid consumes the added base. Okay. In basic buffer, which consumes added H plus in the sense weak base. In the basic buffer, the conjugate acid consumes added OH minus. Okay. Next, we'll see buffer capacity. Buffer capacity we'll see. What is the meaning of buffer capacity? Capacity of a buffer. Okay, that is called buffer capacity. Okay. Now we are taking a buffer capacity word. What is the meaning of buffer capacity? That we will see. Now we will take 1 liter of buffer solution. We will take 1 liter of buffer solution. To this buffer solution will have some pH. This buffer solution is having some pH. To this buffer solution, let us add some acid, otherwise base, anyone. Okay, suppose we are adding acid. Let us add HCl. How much HCl we are adding in the sense such that pH should decrease by 1 unit. If you add acid, pH decreases, though the solution is buffer solution. Okay. If you add base into the buffer solution, the pH increases certainly. Okay, but not normal. Okay. So we are adding acid into this buffer solution. How much acid you have to add in the sense bring the pH of buffer solution to 1 unit less. Here X is the pH means now pH should become X minus 1. For that case, how much HCl is required, that much HCl you add. Okay, suppose you are adding A moles of HCl. So how much HCl you are adding to decrease its pH by 1 unit, that is called buffer capacity. So buffer capacity we can say A moles we can say. Seriya? Sir. Now we will take two different buffer solutions. Now I will take buffer solution A, buffer solution B. For this buffer capacity, I am saying that suppose 2 moles of HCl. 2 moles of HCl. For this buffer capacity is 4 moles of HCl, I am saying. That means 4 moles of HCl required by this 1 liter of buffer solution to decrease the pH by 1 unit. Here, 1 liter of buffer solution A requires 2 moles of HCl to decrease its pH by 1 unit. Okay. Now you say, which buffer solution is better? Which buffer solution is having higher resistance capacity to change the pH? Shall we say B? So B is having higher buffer action. B is having higher buffer capacity. B is having higher resistance power to change the pH when compared to A. Okay, so using buffer capacity, we can compare one buffer solution with another buffer solution with respect to efficiency. So if you want a higher efficient buffer solution, higher resistance power of buffer solution, if you want, you have to take the buffer solution, one which have higher buffer capacity. So if you want higher efficiency regarding buffer solution, if you want higher efficiency regarding buffer solution in the sense, what you have to do? You have to take higher buffer capacity buffer solution you have to take. Okay. Similarly, in terms of base, we will see. Now let us add base. Now let us add base. So what will happen in the sense pH increases? Let pH increase by 1 unit. For which how many moles of sodium hydroxide you are adding? That is called the buffer capacity of this buffer solution. Okay, so on adding base, what happens to the pH of buffer solution? Increases slightly. Now bring the pH of buffer solution to rise by 1 unit, for which how much sodium hydroxide is required, how much minimum amount of sodium hydroxide is required, that is called buffer capacity of this buffer solution. Okay, so if you add base, pH increases. If you add acid, pH decreases. Okay, so now we got a buffer capacity. We got, that means this indicates that how to choose buffer solution. Now we want buffer solution. We want buffer solution in the sense how the efficiency of buffer solution should be there. That point we want. So we should know about efficiency of buffer solution. Efficiency of buffer solution means in terms of buffer capacity. So if you want buffer capacity in the sense if you want buffer solution in the sense which buffer solution you want, that you have to conclude. That means that buffer solution should have how much buffer capacity, that you have to conclude. As per that, you have to prepare the buffer solution and you have to use. So how to prepare buffer solution? In what way we want to prepare buffer solution? Which buffer capacity value you want, with respect to that you prepare buffer solution and use it. So we have to prepare the buffer solution with respect to required amount of buffer capacity, then only we can use it. That means in the preparing of buffer solution, we should consider how to mix the constituents of buffer solution. In what ratio we have to mix, that we have to have an idea. Because buffer solution is having buffer capacity, yes or no? Buffer capacity of buffer solution depend on ratio of constituents present in the buffer solution, yes or no? How do we say there is a relation between ratio of constituents in the buffer solution and buffer capacity? Because you see in this case, it is 1 liter of buffer solution. It requires 4 moles of HCl to decrease its pH by 1 unit. But it requires 2 moles of HCl to decrease its pH by 1 unit.